All right, now on to the last one of the set of problems that we're doing right here. And we're going to start this problem off by the same way that we started off the other problems. And we're going to go and look at this, and we're going to compare this to this and say, what happened here? Is this an elimination or is this a substitution reaction? Just so we can eliminate two of these options here, whether it be substitutions or eliminations. So I'll go ahead and give you a minute to look at that, figure it out for a second. All right, so looking at them, we're going from an OH to an OCH3. So is this bond getting eliminated? It's not. So it looks more like it's substituting, right? You're just substituting this OH for this OCH3 bond. So we can, off the bat, give ourselves a 50% chance by just getting these elimination reactions out of here. So now we're going to go ahead and start to look at, and the thing that I always look at first is your nucleofuge, or the leaving group. Whichever you like to call it, they're the same thing. And it kind of goes back to what we were talking about up here, and what makes a good leaving group. Now, do you remember what I said is when it becomes protonated, or when you add a hydrogen and it's a strong acid, then it makes a good leaving group. So an example of that was like HCl, for example. When we added in a hydrogen to chlorine, it made hydrochloric acid, which you know is a strong acid. Well, what happens when you add hydrogen to hydroxide? Well, you get H2O, and that's not very acidic, is it? It's 7 pH. It's dead center. So it's not very acidic, which makes this a poor leaving group. This thing doesn't even want to leave. This OH right here, it doesn't want to go. It has no reason to. It doesn't feel like it. So that is already one flag or one thing for SN1 is that we're seeing is that this wants to create a carbocation, right? And the big difference between SN2 and SN1 is that this guy will form a carbocation and this guy won't. So that's already one for the fact that it's going to create a carbocation. But we'll go further. We want to be clear, right? We want to be thorough. So let's go and move on. So the leaving group you have to look at, where's this OCH3 coming from? Well, it must be coming from here, right? Because there's no carbons up here. Okay, well, the problem with this is that, yes, it looks a lot like what we were just dealing with here, right? CH3ONA and CH3OH. The difference is that this hydrogen is not like that sodium metal. It's not happy with just leaving like that. It doesn't want to just go, and it's not just going to it's just not going to ionize in solution. So on top of this not wanting to go, these guys aren't particularly looking to just go ahead and split up, right? So they will, but it's not going to be particularly fast, and you'll end up forming CH3O minus and H plus in a solution that's already acidic, and this H plus just adds to that. So what will eventually end up happening is that this OH group will leave. It's not a good leaving group, that's for sure, right, as we went over earlier, but it is a leaving group in general. It will leave. And it'll form OH minus, right? And then that will go ahead and react with our H3O plus, which is just OH minus plus H3O plus, creates two water molecules, right? And our something we learned from Gen Chem, which is what it's telling us right here. We do form water. And then we're left with our CH3O minus, which is cool because this minus right here, this oxygen, is going to want to pick up that bond after this thing leaves. The only problem is that that's not going to want to leave very fast, right? So if that doesn't want to leave very particularly quickly, then we're probably going to form a carbocation, right? It's going to be slow after all. It's not all going to happen in one step like SN2 would suggest, because remember, SN2 is bimolecular, aka both steps are happening at one time, whereas each step is happening one at a time in SM1. So you've got the carbocation, and then you've got the addition of the nucleophile onto that carbocation to make OCH3. Which makes sense. So likely what do we have here? We have something that's going to form a carbocation because this didn't want to go particularly. And these guys will disassociate, but they didn't want to go quickly. And that nucleophile will want to go there. Is it going to push it directly out? No. And is this guy going to take a little bit of time to leave? Absolutely. So there you go, SM1.